Okay, so if we want to find the mass of some planet, something like something based off of a moon of Jupiter, so if we even look at Pluto, we did not know the mass of Pluto until we discovered that it had a moon. So let's look at what we need to solve for that. So typically speaking, we would be able to know the radius of the orbit. So if we're looking at some sort of moon of Jupiter, Io, or any other of its moons, there's going to be some radius, whatever that may be. Let's just say that is, I'm just going to say that it's known. I don't really care what it is. Let's just say that the radius of the orbit is known. We also have the time period. That's fairly easy. That's going to be observed, so it can be known as well. So it's going to be measured in some amount of time. Here's the idea that I want to get through. So we have the universal law of gravitation. That is going to be the force is equal to big G times m1, m2 over r squared. And we're going to express that. We can also make that equal to mg, where let's say that it's m2g. We're looking at the second object. The second object would be the moon in this case, and it is accelerating at some rate. Typically, we wouldn't necessarily use g, would use a in that case, because it is accelerating at some rate at its position. Well, that's a centripetal acceleration, radial or centripetal acceleration. So instead of it being an a, let's say it's v squared over r. And that object, again, we are looking at the amount of time it takes for it to go around. We're looking for r. So we're going to make the statement that for something moving in a circle, the velocity is equal to 2 pi r over t. So it's the circumference of the circle divided by the time it takes to go around once. So we're going to take that and we're going to substitute that in to v within this equation. So let's go ahead and do that. So by taking that, we're going to say it's going to be equal to m2 times 2 pi r over t, squaring it, and that's all over r. Let me move this over here. That in turn gives us m2 times 4 pi squared r squared over t squared, and that's all over r. And I'll continue on to the next line here. That is, let me rewrite this part here because I'm going to need that. That is the same thing as m2 times 4 pi squared times r over t squared. Okay, this simplifies down into that. All right, and now all we need to do is cancel out the mass of the moon because it's on both sides. We have r, we have t, and we can solve for this mass. This is what we're trying to solve for, the mass of Jupiter. So I'm just going to go there in terms of variables. So multiply each side by r squared. That gives us r cubed on the right, and divide by g. So the mass of Jupiter, or whatever planet we're looking at, is equal to 4 pi squared times r cubed over g times t squared. There's our final equation. Remember that we got there because we are going to say that the universal law of gravitation is the same thing as the centripetal force, and we just express that v is 2 pi r over t and do a little bit of substitution in there. And that will get us to the mass of that planet. And that's how we know to find the mass of any planet within the solar system. All right, there you go. Just want to show that to you, and that'll take care.